Okay, in 7.3 we're going to be learning about the Pythagorean theorem. So here's the key idea. The sides of a right triangle have special names. The Pythagorean theorem can only be used with right triangles. What makes it a right triangle is that there is one 90-degree angle. The legs are the two sides that form the right angle. So no matter how the triangle is labeled, you will always know which two sides form the legs because the right angle will be between them. The side opposite of the right angle is called the hypotenuse. The hypotenuse is also the longest side. So if we were to label them A, B, and C, we could then use algebra to describe the Pythagorean theorem. So in words, it says that in any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. And I know that's a lot of words. And what that basically means, looking at the leg A, if we were to form a square at leg A, okay, it may not be perfect, but the area of this square, okay, would be just, described as A squared, because the side length is A times A squared. Then if we had a square at leg B, okay, again, not perfect, the area of this squared could be described as B squared. Finally, consider the fact that there would be a square also from the hypotenuse, right? Not very square, but we'll make it work. And that would be called C squared. So that if you added the area or the amount of space taken up by the square with side length A and the amount of space taken up by this square with side length B, they would be equivalent to the amount of space taken up by this square, C squared, with side length C. So if I could, I wish I could superimpose it or show you some kind of a, interactive that would allow A and B to both fit inside and be equal to C, and that allows us then to find any missing side. So the first examples we'll have a side length C that is missing, the hypotenuse, and then we'll experiment with and do examples with the legs, side lengths that are missing. Well, this is a pretty great and very useful formula and theorem in mathematics. So let's take a look. Finding the length of the hypotenuse. Remember, this is the longest side. So looking at the triangle, you have A equal to 5 meters, B equal to 12 meters, and you can see from this example, which is right out of your book, A squared plus B squared equals C squared. So if you take 5, side length A, and square it, you get 25. If you take 12, side length B, and you square it, you get 144. And when you add those two quantities together, the sum, 169, would be equal to C squared, or the area of a square with side length C at the hypotenuse, so that the square root of both sides then gives you the side length C. So we have 13 meters. We'll try that. Here's our first one. So find the length of the hypotenuse. So we have to determine which part is A and which part is B. So we'll write the Pythagorean theorem, A squared plus B squared equals C squared. Substitute in the values. Okay, 15 squared is 225, 8 squared is 64, and when we add them, we'll get the area of a square that would be located at the hypotenuse. So 225 plus 64 is 289. That's equal to the area of the square. So to find the side length, we've done that. We take the square root of both sides, and we find that 17 feet is equal to C. Don't forget to have your dimension unit. So in this case, we had to have a label of feet. Looking at number 2, we can make this side A and this side B. It really does not matter because addition is commutative. So 2 over 5 squared plus 3 over 10 squared equals C squared. Remember, when you have a fraction, you square the numerator and you square the denominator, so 4 over 25 is equal to plus, that's a squared, and this is b squared, over 100 is all equal to c squared. I apologize for that. So 4/25 plus 9 over 100 is equal to c squared. To add fractions, we must have a common denominator, and we can easily multiply the first numerator by 4 and denominator by 4 and rewrite this to be 16, an equivalent fraction, 16 over 100 plus 9 over 100 equals c squared. 16 plus 9 is 25, so 25 over 100 is equal to c squared. So taking the square root of both sides would give us 5 over 10, which could be simplified to 1 over 2 inches, that is equal to c. So ½ an inch, and if you do it in decimal form, that would be fine. But don't forget that working with these fractions are pretty easy because we're just squaring and taking the square root of some very small perfect squares. You could even do that without the use of a calculator. Okay, sometimes one of the legs is missing. So using the same formula, we're going to substitute in 2.1 for b and 2.9 for c. Remember, the side opposite the right angle is c. So your formula, a squared plus b squared equals c squared, would turn into a squared plus 2.1 squared is equal to 2.9 squared. When you square both of those, you have a squared plus 4.41 is equal to 8.41. So what you're doing here to solve this equation is you are subtracting 4.41 from both sides, right? Just a little bit of basic algebra here. Right, because 4.41 minus 4.41 is 0. We're left with a squared. When we get 8.41 minus 4.41, we're left with 4. So a squared equals 4. The square root of both sides gives us a is equal to 2, so 2 centimeters. We'll have a couple that we can try. Finding the missing side. Again, making sure you know which sides are the legs and which side is the hypotenuse. So if you need to label them, okay, because this one was already labeled b, we would have 16 squared plus b squared is equal to 34 squared. So go ahead and square them on the calculator if you need to. 34 times 34 is equal to 1,156. Since we're solving for b squared, we must subtract 256 from both sides. Okay, that leaves us with b squared. And when we subtract, we get 900. If b squared is equal to 900, the square root of that would give us b equal to 30 yards. Okay? So again, if you need to label on number 4, the missing side, so that you make sure to put the numbers in the right place. Always look to find c as opposite of that right angle. So a squared plus b squared equals c squared. We don't know a. 9.6 squared is equal to 10.4 squared. When you square this decimal, you'll get 92 and 1600ths. That's equal to 108 and 1600ths. To solve for a, subtract 92 and 1600ths from both sides. We've had a lot of examples and lots of practice solving equations. So in this case, we'll get 16. When you take the square root to get a by itself, it is equal to 4 meters.